Viewers, this is the video lecture for the topic attribute grammar. This topic is for the first unit syntax and semantics of principles of programming languages. An attribute grammar is a formal way to supplement a formal grammar with semantic information processing. Semantic information is stored in attributes associated with terminal and non-terminal symbols of the grammar. The values of the attributes are the result of attribute evaluation rules associated with the productions of the grammar. Attributes allow to transfer information from anywhere in the abstract syntax tree to anywhere else in a controlled and formal way. Attribute grammars have additions to CFGs to carry some semantic informations on parse tree. In simple applications such as evaluation of arithmetic expressions, attribute grammar may be used to describe the entire task to be performed besides parsing in a straightforward way. In complicated systems, for instance, when constructing a language translation tool such as a compiler, it may be used to validate semantic checks associated with the grammar representing the rules of a language not explicitly imparted by the syntax definition. An attribute grammar is a context-free grammar with the following additions. For each grammar simple x, there is a set a of x of attribute values. Each rule has a set of functions that define certain attributes of the non-terminals in the rule. Each rule has a set of predicates to check for attribute consistency. Let x0 implies x1 up to xn be a rule. There are functions of the form s of x0 equal to f of a of x1 up to a of xn define synthesized attributes. Functions of the form I of xj equal to f of a of x0 comma up to a of xn for I lesser than or equal to j lesser than or equal to n define inherited attributes. Initially, there are intrinsic attributes on the leaves. Syntax rule. Procedure define. PROCDF implies procedure name 1. So procedure body, end procedure name 2. Predicate. Procedure name 1 string equal to procedure name 2 string. Syntax. So this is the grammar, context-free grammar. Assign implies variable equal to expression. Expression implies variable plus variable or variable. Variable means A or B or C. Actual type synthesized for variable and expression. Expected type inherited for expression. Then these are the semantic rules, predicate and syntax rule. Then these attribute values will be computed. If all the attributes were inherited, the tree could be decorated in top-down order. If all the attributes were synthesized, the tree could be decorated in bottom-up order. If all the attributes were synthesized, the tree could be decorated with bottom-up order. In many cases, both kinds of attributes are used, and it is some combination of top-down and bottom-up that must be used. Parse tree. So this is the symbol parse tree, basic parse tree. The values will be substituted by referring from the grammar, and we are producing the statement a equal to a plus b, and this is then the attribute values will be computed and flow of attributes in the tree. So here the same tree will be the attributes will be applied by the previous evaluation, and these attributes will be applied on the parse tree. So assign variable actual type, expected type, expression, variable 2 and variable 3 will be substituted for the expression, and so in every points actual type will be compared against the expected type and the final values will be substituted. A fully attributed parse tree. So here we can see in every nodes the attributes will be substituted. Actual type equal to real type, expected value equal to real type. So in this way we can see attributes will be substituted in all the nodes of the parse tree. So that's all about the topic.